Hello and welcome to lesson 2E on algebraic proofs. In this lesson, you're going to learn how to write a two-column algebraic proof. Guys, you have been simplifying algebraic expressions or solving algebraic equations for a really long time. And when you do that, you're utilizing all of these mathematical properties that we just haven't made you name up to this point. What we're going to do is we're going to solve algebraic equations by justifying every single step you make. You are responsible for knowing and being able to use the properties below. Now, some of these properties can be used in either congruence or equality. If given the choice between a property of congruence or a property of equality, look at the phrasing of the problem. If the problem is referring to congruent figures, we're using properties of congruence. If you were referring to specific values, we'll be using properties of equality. Now, the first four are ones that you use all the time. If A equals B, then A plus C equals B plus C. Basically, if I add something to both sides of the equation remains balanced. Subtraction property is the same thing. If A equals B, then A minus C equals B minus C. You've been using this over and over again your whole life, had not even realized it. Multiplication property is the same idea, as is division property, with the caveat that you cannot divide by 0. Now, here are your new properties. These guys are your new ones. If I know that something equals itself, A equals A, we call that the reflexive property of equality. We haven't used it a whole lot up to this point, but you're going to start using it in geometry when we start proving things congruent to each other. The next property is the symmetric property of equality. If A equals B, then B equals A. Or if X equals 2, then 2 equals X. And the third is the transitive property. This is almost like a chain reaction property. If A equals B and B equals C, then A equals C. So those are your three new properties. We also have the distribution properties of equality. Basically, it just says that you're able to distribute either over addition or over subtraction. You've used this a ton in the past. Substitution property says that if you know A equals B, then you can replace A by B. This only works for numeric values, including algebraic expressions that evaluate for a number. Substitution is never a valid property of congruence, so just be aware of that. You're going to have a knee-jerk reaction to use it for congruence, but you can't. Usually it's transitive property instead of substitution property. So properties of congruence that you'll use, something is congruent to itself is the reflexive property of congruence. Your symmetric property of congruence says that if AB is congruent to CD, then CD is congruent to AB. Or if angle X is congruent to angle Y, then angle Y is congruent to angle X. And your transitive property of congruence is, again, that chain reaction property. If AB is congruent to CD and CD is congruent to EF, then AB is congruent to EF. So let's take a minute and work on identifying which property we're seeing in all of these. If X plus 5 equals 9, and my next line is X equals 4, what did I do to go from this line to this line? Well, what I did was I subtracted 5 on both sides. So we would call this the subtraction property of, this is equality because I'm using an equal sign. That means it's a property of equality. Well, let's look at number 2. Negative 2x equals 12, then x equals negative 6. What did I do to go from here to here? Well, I divided. So this is the division property of equality, and I'm going to use POE for property of equality. And now this next example, what did I do if I have 3 times x minus 7? Then my next line is 3x minus 21. What I did was I distributed. And I distributed over subtraction. So I'm looking up here at these names. This is the distributive property of multiplication over subtraction. Now, I am not going to make you always write out over subtraction. So if you want to just call this the distribution property of equality, I am just fine with that. Now, let's take a look at some more properties here. If x equals y and y equals 3, then x equals 3. This, guys, is your chain reaction. X equals y equals 3, x equals 3. This is transitive property. A lot of people want to call this the substitution property, but whenever you're taking whole sides of equal signs and replacing them with other whole sides, it's really the transitive property. Segment AB is congruent to segment AB. That's your reflexive property. And because we're dealing with a congruent simple, it's really property of congruence now, not equality. We change signs. And in geometry, we like to make a distinction between being congruent and being equal, even though they mean very similar things. They're not quite the same idea. Now, number 6, I want to show a cascade of logic here for you, okay? Angle G and angle H are each 35 degrees. Well, that's something that I've just been given. So I'm going to call that a given. We use lots of givens in our proofs, okay? Therefore, I know that the measure of angle G equals the measure of angle H. They're equal to each other. If they each equal 35, therefore they're equal to each other, I would call that transitive property. Property of equality now. And if two things are equal to each other, then they are congruent to each other. We're able to say that they're congruent to each other based on the definition of what it means to be congruent. I know this is not a property, but I want to draw a distinction here. This is saying because they're equal, therefore they're congruent, and they were equal because they're both 35 by the transitive property. All right, now, number 7, given the figure below, the measure of angle A is x plus 5 degrees. Guys, this is the kind of thing, whenever you see the word given or you've got a picture, we're going to say that that's just given in the diagram. Given in diagram. So not really a property of equality or a property of congruence, just something that you're given. So now let's actually start applying this stuff. The properties can be used to justify each step in solving an equation. When we're writing a 2-column proof, we always list our statements in the left column and our reasons for each step or our justifications in the right column. For an algebraic proof, basically, you solving the equation numerically goes in the left column, and why you're able to do what step you're doing goes in the right column. So, below is an algebraic proof solving the equation 10 equals 2 times 3x minus 4. And the first thing we want to do is we write the equation we start with, and we're able to write that because that's what we're given. Then my next step was I distributed, and I wrote it out without actually solving it. 2 times 3x minus 2 times 4. I wrote it out because that's distributive property of multiplication over subtraction. That's what's going on there. And then the next step, all I did was I took the numbers and I simplified them. It's not a property of equality because we didn't cross an equal sign. So I wouldn't call this the multiplication property of equality because nothing switched sides in this equation. It all stayed on the same side. We just simplified the numbers. Then to go from step 3 to step 4, what I did was I added 8 to the other side. So my reason for step 4 was the addition property of equality. And to go from step 4 to step 5, I divided both sides by 6. And if you notice, when I divide both sides by 6, my x is still on the right-hand side of this equation, the y on the left. I can't flip it around in the same step. That's a different property of equality. Notice I'm doing only one thing per step. So step 5 was division property of equality, whereas step 6, when I flip it around to get that x equals 3, that's my symmetric property. I couldn't do these in the same step. I have to do them in 2 different steps. So let's do this one together. I've got an algebraic proof of the equation 3/2 x minus 5 equals 9. My first reason when I copy down the equation is always given. Then I look and I see that in order to solve this with a fraction, it's probably easiest to multiply everything by 2 to clear the fraction, which is what I did in step 2. And so that was the multiplication property of equality. So you can shorten words. I'm okay with you shortening every single word except do not shorten subtraction and substitution, because subtraction and substitution are almost the same word when you're shortening them. So we're just not going to play that game. You're not going to subtract, you're not going to shorten subtraction or substitution. All right, then to go from step 2 to step 3, I added 10 to the other side. So that's the addition property of equality. And to go from step 3 to step 4, we divided, so that's my division property of equality. All right, let's take a look at this next question here. I've got the equation 5x plus 1 times 3 equals 18. So my first step, notice I'm numbering my steps, is to write out what I'm given. 5x plus 1 times 3 equals 18. That's my given. Now, I've got two options here. I could divide off the 3, or I could distribute the 3. And what I think I'm going to do is I'm actually going to distribute that 3. So step 2 is 3 times 5x plus 3 times 1 equals 18. That is distribution property of equality. If you wanted to tell me that it was over addition, I'd accept that, but I'm not going to force you to do that. Then I'm going to simplify that. So it becomes 15x plus 3 equals 18. And guys, this isn't a property of equality. I didn't actually flip anything over. So this was simply simplification. And it's not a property of equality. Now I'm going to subtract the 3 over to the other side. So step 4, I get 15x equals 15. So that's subtraction, property of equality. Notice I did not shorten the word subtraction. And step 5 is the very nice and easy. I divide by 15, so I get x equals 1. So that's division, property of equality. All right, guys, that's the end of this lesson. Go ahead and take a look at the MML. Thank you.